Welcome back with another video on our channel. This is Zahid Nazir and we are doing Advent of Cyber 2024 on TryHackMe.com. So this is day 6 for me, although the day 10 is also released. So in this particular task, which is related to the sandbox and the day 6, if I can't find a nice malware to use, I am not going. All right. So before we continue, as you can see here, we don't need to start the attack box. We do need to install start the VM at least, and split view is available. Yes, we already initiated, and we can also go with the RDP if we don't want to use the split view. Okay, so these are the credentials. Let's start from very beginning as we do in all our other videos. So here we go. Mere malware was scheming, quite full of delight to ruin SOC mass, frighten SOC teams, but Glitch and MaxKitty had spoiled his plan by uncovering secrets that expose the man. Awesome. I like this one. I like the background image that they have used, and it's a FlareVM as well. So we have floss.exe, some tools, and PS TypeScripts here. I can see what is this one. This is CFF Explorer as well. So this is a different machine, by the way. Continuing. Mere malware slammed his hands on the table, his eyes narrowing as the report flashed on his screen. The Glitch and MaxKitty had uncovered his trail. How he get to know all of this? He took a deep breath, calming himself. No matter, he muttered, a sinister grin forming. They may have found me, but haven't stopped me. His confidence stemmed from the malware he had crafted, so devious and advanced that it would easily evade detection. Awesome. Wow. But before unleashing it to wreak havoc on SOC teams and ruin SOC mass, there was one final step. He needed to test it in the sandbox. Okay. So he already created a devious malware. He just want to test it in the sandbox environment here that we have on the right hand side. Learning objectives: analyze malware behavior using sandbox tool, explore how to use Yara rules to detect malicious patterns, learn about various malware evasion techniques, implement an evasion techniques to bypass Yara rule detection. Okay. Connecting to the machine. Before moving forward, review the questions in the connection card shown below. Okay, we already did so. Click on the green button. We did so. It is showing in the split view, and this is the information about the VM itself, IP address, user and password. Okay. He slipped his malware into a sandbox to see what tricks it could play and what flaws there might be. For sandboxes, you see or used by the wise, defender inspect, but attackers revise. Wow, they have a real rhyme to this particular point. Detecting sandboxes. A sandbox is an isolated environment where malicious code is executed without affecting anything outside the system. Often multiple tools are installed to monitor, record, and analyze the code's behavior. Mere malware knows that before his malware executes, it needs to check if it is running on a sandbox environment. If it is, then it should not continue with its malware activity. To do so, we have settled on one technique which checks if the directory C program files is present by querying the registry path here. Okay. So it is HKLM software, Microsoft Windows, and current version. The value can be confirmed by visiting the registry path within the registry editor as shown below. Okay, let's do that. Either you can just search for registry, or we can search for run. There it come, and use the command regedit, which is already there. Click OK. Here we go. So we need to go with HKLM local machine. So here we go. Software, Microsoft. Here we go. Current version. Current. version. I don't see any current version. Windows, sorry. Simple Windows. This is current version. All right, and program files. Dire. Here we go. So this is dire. To open the Windows start menu, select the run. Yeah, we already did so. This directory is often absent on Sandboxes or other virtualized environment, which could indicate that the malware is running in a sandbox. Really? Okay. Here's what it looks like in the C programming language. We have a function registry check const value with a pointer to this string, and string pointer for program files dir. Then prepare the command string for rich.exe. Here we go. Sn printf command size of command and the registry query, and we are printing its name. Run the command system dot. System is the particular function provided by different programming languages such as Python, I think, and also in PHP and C++. We just pass system and then the command, and it will execute and give you the result. So if the result is 0, then that means it is successfully executed. If not, then it is not. Alright, moving forward. Don't worry, you don't have to understand every detail of the code. All you need to know is this function is designed to check the system registry for a specified directory path, which is program file dir. Did we? Yeah, we already checked. So this path's presence or absence helps the malware determine whether it's running in a typical or virtualized environment like a sandbox. Okay, can Yara do it? Mere malware knows the MaxKD is a big fan of Yara rules. Yara is a tool used to identify and classify malware based on patterns in its code by writing custom rules. Analysts can define specific characteristics to look for, such as particular strings, file headers, or behaviors, and Yara will scan files or processes to find matches, making it invaluable for detecting malicious code. Mere malware does not think such a simple tool can detect his malware, but just to be sure, he has to test it out himself. Okay. To do this, he wrote a small script that executes a Yara detection rule every time a new event is added to the system monitor log. This particular Yara rule detects any command that tries to access the registry. Let's have a look at the rule. Okay, so the rule is sandbox detected. Meta description is detect the sandbox by querying the registry key for the program path. Author is TryHackMe, date and version, and then this is the string that we are looking for. This is the command, software, whatnot, and V. Then the program files, no case, condition, and then we just execute the command. Let's understand the contents. In the strings section, we have defined variables that include the value to look out for. So this is the command value that we are looking for. Any command which will have this particular string and pointing to this particular program files or dir entry. Okay. So this is what we're looking for. In the condition section, we define when the rule will match the scanned file. In this case, if any of the specified strings are present. Okay, so a good way to do to avoid this detection is to encode this particular string, so you will not able to see it because we are not decoding the strings here anyway. So if we encode our string, I think we will be able to avoid this detection. Let's see what kind of solution they will present here. For his testing, Mere malware has set up in one function script that runs the Yara rule and logs a true positive in C tools yaramatch.txt. Open up a PowerShell window, navigate to the C tools directory, and use the following command to start up the EDR. Jinglebells.ps1. Okay, this rule will run on the system and continuously monitor the generated event logs. It will alert you if It finds any activity event that indicates the registry mentioned above key is being queried. Now run the malware to navigate to the C tools malware and double click on the malstrings.txt. Okay, so before we do anything here, let me minimize this and let's open up our PowerShell. So our tools are on the desktop, C tools, right? Okay, so let's go to this C tools. We are here. Dire. Here we go. So we need to run the jingle bell. Jingle bell. I just type the jingle bell and press tab key. It automatically what you say completed for me. Okay, I press enter. The event found in the system log. Okay, no event. So it is keep on running. Let's go to the tools, which is basically on desktop. What you are looking for, malware. Okay, this is not the right folder. Let's go to C tools, malware, malstrings.txt. Okay, so we run this. Let's see. Oh yeah, I found it. It found it. Error result. Malicious command detected. THM glitch was here. Okay, can we copy it? Okay, maybe this is the flag. Let's put the flag. EDR detection. So it is THM glitch was here. Okay, so the first flag is done. Where we were. So here we were. So it is detected and we have the notification. I click on OK. So here's the detail of everything here. So we did the Merry Christmas and you can see it detected the basically command line, which is this query, and this is the string that we were looking for, and all of other information is like this, as you can see. Note if the power does not show up, however, the PowerShell item in the taskbar, it should show the pop-up that was generated. Okay. If our custom script did its job, you should have witnessed a pop-up by our EDR. So it is endpoint detection and response with the flag included. As shown below, this will be the answer to question 1 below. You can now exit the custom EDR by pressing the Control C. Okay, so let's press Control C. I did so. Why it is not exiting? Yeah, okay, now it exited. Okay, adding more evasion techniques. It seems that the Yara can detect the evasion that mere malware has added. No worries, because we can make our malware even stealthier by introducing obfuscation. So obfuscation is the action of making something obscure, unclear, or unintelligible, like this string here. So the encoded PowerShell command to query the registry. Now it is encoded. I think they are using base 64. Can we check it? Let's go to the cyber chef. Let's go here. Let me get it here. So here is the input, and from base 64, I don't see it. Get item property. Yeah, I can see it, but I think I need to do something in order to make it more readable. I'm not sure which one. Maybe I need to remove the null character. Remove null bytes. Let's see what happens here. Yeah, here we go. So this is the actual command. As you can see, this is a PS command, a PowerShell command, get item property. We are giving it the path and the name of the value that we will need to get. All right. Let's go back. Prepare the PowerShell execution command. It is the same as before. Everything looks good. Okay, code explanation. Yeah, they are using also server Chef. The above code does the same thing. Query the same registry key to get the information and about program data. The only difference is that the query is now encoded using base64 and the code uses the PowerShell to execute the query. The encoding can be checked by decoding it using a tool like CyberChef. We have done so. We have done the same thing. Be aware of floss. By obfuscation is, while obfuscation is helpful, we also need to know that there are tools available that exact obfuscated strings from malware binaries. One such tool is floss, a powerful tool developed by Mandiant that functions similar to Linux strings tool, but it is optimized for malware analysis, making it ideal for revealing any concealed details. Okay, so floss.exe. All right, let's see. There is a floss directory, so let's go into the floss directory here. Hey, what is happening here? cd floss. Okay, let me make it bigger. I press enter. Okay, so let's execute the floss itself. Okay, so what we need to do is, as per the argument, I think floss.exe, then we need to pass the string itself, and then the output file is this one. So let's copy all of this and let's execute. I hope I can do that. Edit, paste. Why it did not take it? Do we have? Okay, let's do one thing. Let's type all of it. Floss.exe. Then we need C tools malware Merry Christmas.exe out file. Then the file that we need it to be the tools malstrings.txt. Let's see. So floss extracting these static strings. Okay. Analyzing the program. Okay. In the meanwhile, let's go through the text we have here. The above command can take up to 2 minutes to complete. In the meanwhile, let's break down the command. Floss.exe, C tools malware merrychristmas.exe. This command scans for the strings in the binary merrychristmas.exe. If any hard-coded variables were defined in the malware, the floss should find them. The pipe symbol redirects the output of the command in front of it to the input of the command behind it. Okay. Out file C tools malware-string.exe. We save the command results in the file called malware string. So let's go to the string file. It should be in the tools and malware strings.txt. So here we have all the strings that are available. This program cannot be run in the DOS mode. Okay. quite a long one. Okay, these are the strings we have. GCC. Plus static strings UTF-16 LE, so we cannot read it basically. All of else is, I think, the call stack or something like that. It looks like stack or something. Okay. Once the command does open the string, press Ctrl F and search for the string malware. Mere malware. Okay. Let's find. Okay, let's go with the THM is already there. So here we go. THM hidden clue. Enter the flag as the answer to the question 2. The format of string is this one. Okay. This was very interesting. I love it. We learned a lot. Using Yara rules on sysmon logs. These Yara rules are becoming a pain to mere malware's backside. Okay, if he wants his malware to be undetectable, he needs to research how Yara rules can be used to stop him. For example, his research tells him that Yara rules can also be used to check the sysmon logs for any artifact left by malware. He will need to test this as well. Sysmon, a tool from Microsoft System Internal Suite. So Sysmon tool, sometimes it is available on VMs and Docker images, and sometimes the administrator or the cybersecurity personnel or the professional will just block anything which is part of Microsoft's Sys internal suite. Okay, why they do that? So nobody can do the administrator level things that we are discussing right now. Okay, and this means if they need to do anything, they should open a ticket with the cybersecurity or the VM team or whoever is handling that particular solution in order to get the logs and in order to use these tools. Okay, so that's why it is, and this system internal tool can be used to manipulate the files on the system. So these are very useful and also very dangerous if you consider cybersecurity. So that's why if you are working with an organization who is mature enough in their cybersecurity policies and all these things, so you will know that if you try to execute anything, any tool from the system internal, they will send you a big email that why you did that and why you are trying to use these internal tools. Okay, because the development and all these things does not need these internal tools to do your activity. So continuously monitors and log system activity across reboots. This Windows service provides detailed event data on process creation, network connections, and file changes. Valuable insights when tracing the malware behavior. Yara rule will look for events with event ID 1 process created. For this to work, there are many entries in the syslog, sysmon log. To make it easier to find the event we are looking for, we will apply a custom filter using the event record ID that we can see in the log Yara matches.exe string located in the ctools. Okay, let's open that one. So here we go. So these are the things that were matched and log is here. Okay, open PowerShell window and enter the following command to check the contents of the EDR file. Okay, here we go. We already have this one. I will make it clear. Get content basically is cat command. Can I paste it? Okay, yes, paste is not working. I don't know why. Content C. Wait. tools, Yara matches. Okay, these are the contents of the file. It's basically cat and the file name in the Linux version of the command. You should get a result similar to the output below. Yeah, we did get the same result. All right. Note down the event record ID value. So here we have 1279 and 49, 1279, 48. Okay. We will use this value to create a custom filter in the Windows event viewer. Next, open the Windows event viewer. Here we go. By clicking on its logo in the task bar and on the left, navigate to the application services logs. Here we go. Give it a few seconds. It will load the contents beneath it. We need to go to the Microsoft Windows, Sysmon and operational. Microsoft Windows. Just search for it. Sysmon operational. So I select any of the node here and press then SYS. It will directly go to the name that we were searching for. Okay, so this is a shortcut way to do that. Okay, continue by navigating to filter current log. Where is it? Filter current log here. You should see a windows like the one below. Yes. Okay, navigate to the XML and tick the checkbox edit query manually. Okay, yes. Replace the event record ID. Event record ID is this one. Which one they are using, by the way? Apply the filter by clicking OK. So I hope this will work. So system path and okay, wait. So this is the ID that we were looking for, but we need to basically add this particular query. Paste, and here is my ID. We need to insert it here. All right, we did so. Replace the event record ID. We did so. Value with the one you recorded before. Apply the filter by clicking OK. We did so. Oh, we just have one. Okay. Now get the event related to the malware. Click on the event, then on the details tab. Details tab. Here we go. Okay. We have all the information. Let's take a look at the event data. Sure. Here is the event data. Parent image. Reconnect. Why you are doing like this? Okay. Hopefully everything is okay. So the parent. I don't see parent image. There is an image. Yeah, here we go. Parent image. It is Windows System32 and command.exe. Okay. He knows us which parent process spawned the command.exe process to execute the command. We can see it was our malware created ads. No, I don't see it. It is just wait a moment. There should be other information as well. The regex. Am I missing something here? Because this is the okay. Let's go with the 48. Okay. instead of the other one. Let's go with the 4, because in here basically command result is there, but in here this is the actual starting point. Okay, let's go with that 4.8. So in order to do that, let's go with the filter grunt. Let me go with 8. Press OK. Now I think we'll get to now this is the command, and where is the parent image, man? Yeah, here we go. So the parent image is malware Merry Christmas.exe. Alright, so this was the tool which started this command. Okay, now we get it. The parent process ID and process ID keys are valuable for follow-up research. We could also use them to check other logs for related events. So this is the parent process ID and process ID. Alright. The user key can help us determine which privileges were used to run the command. A user. So this is parent user, administrator. But where is the user? Yeah, here is the user, which is also our administrator. Help us determine which privileges were used to run the command.exe command. The malware could have created a hidden account and used that to run commands. The command line key shows which command was run in detail, helping us identify the malware's action. The UTC time key is essential for creating a time frame for the malware's operation. This time frame can help you focus your threat hunting efforts. Never gonna give up. His malware, it seemed, wasn't quite ready for town. There are watchers and scanners and rules by the ton. If I am not careful, they will catch all my fun. Mayor Malware leaned back, tapping his finger like this and thoughtfully on the table. All of his research has revealed an unsettling truth. His malware, as cunning as it was, wasn't yet ready for the wild. There were too many tools and too many vigilant eyes, analysts armed with Yara rules, Sysmon, and a host of detection techniques that could expose his creation before it even had a chance to spread. Okay, so here he is very frustrated, as we can see in the image here. He clenched his fist and determined glint in his eyes, just a little more fine-tuning. He murmured he would study, adopt, and evolve. Okay, so this is the mantra of, I think, US SEALs, I think, US Army. Adopt, overcome, or something. What was it? Adopt, overcome, and conquer, I think, or something like that. His malware, until it was truly undetectable, when the time was right, he would unleash it upon the unsuspecting SOC teams, striking when they least expected it. But for now, he would wait, watching, planning, and he was perfecting his craft in the shadows. Awesome, awesome. If you want to know more about the sandbox, you can go here, FlareVM, a arsenal of tools. I want to know, okay, so this is a part of the defensive security tooling, cyber security 101. So I have done a lot of rooms in cybersecurity 101, so it is part of the tooling. So maybe in a couple of few videos, I will get to go through this room as well. So I'm gonna close it for now. So click on complete, and we have done with the day 6. So thank you guys for joining me on this journey. I am enjoying it a lot. We learned a lot in this room, especially how we can go and go through the logs that are generated by Sysmon, or the event logs, and are available in the category of Sysmon, and we were able to pinpoint which process actually executed the command. That is really helpful in our forensic analysis things. So If you enjoyed this video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build the community. And I will be back in another video. And if you have any comments, please don't forget to mention in the comment section below. And I will see you in the next video. Bye bye.